Hello guys, in this video we'll be seeing how to write a onboard blink LED program. So a LED is a small light, it stands for light emitting diode that works with relatively less power or little power. And Arduino board it has a onboard LED in pin number 13. So we have a pin 13 which has an onboard LED on our Arduino. So the blink LED program takes a few lines of code, and what we have to do is basically we have to define some variables, then we have to write input and output for that. So we'll be seeing the program for that. Now before that I would like you to show you the pin diagram for Arduino. That is, if you see this picture, this is our Arduino and this is the Atmega 328P, the chipset what is being used in the Arduino. So you can see this is the chip, basically this is the chip what we have used in the Arduino. And in this pin number 13, if you look carefully, pin number 13, that is nothing but 19th pin of this Atmega. This is internally connected to a LED. So if you see a diode with an arrow mark outward, that means it's an LED. So pin number 13, that is nothing but it has an onboard LED. So in Arduino, next to 13 pin number, so you can see an LED. So that is the onboard LED, and exactly the same we have here. So next to 13 we have an LED here, so that is the onboard LED. So that is the program what we will be writing in this video. Okay, so initially how do we write the program? Now first thing first, as you know, the void setup and void method loops. So in void setup, before writing void setup, I have to initialize variable. Yes, so I'll create a variable called as in LED, and I'll say the LED in pin number 13 because it is on pin number 13. And then in void setup I have to go and I have to specify, right? So which mode I'm using. So pin mode, I'm using the pin number 13, that is this LED, as an output pin. That means it is giving out the voltage. And inside, coming to my loop part, so what do I write in my loop part? So inside void loop, first thing I have to write digital write, because I'm giving a digital write. Digital write is nothing but giving a discrete value. So when I say discrete value, it is 0 1, it is either 0 volt or 5 volt. So that is discrete value. So now if I write this digital write and I'll say pin number 13, that is stored in my variable LED. So I'll write digital write LED comma high. That means it should be high. That means 5 volt should be given as output. Now after giving that, I need to give some delay. So in order to give some delay, I use the delay function, and I have to pass here in milliseconds. Whatever argument I'm passing, it is in terms of milliseconds. So 1000 milliseconds is equal to 1 second. So it's going to halt for a second, delay for a second. Then again I'll be writing digital write pin number 13, that is LED, as low. Now once I write a low, then I have to again give a delay, right? So it should stop, or else it's going to bring very fast, that would not be able to see from our naked eyes. So I give a high, then I give a delay, and then again I write a low, and then I give a delay. So this way what happens, you know that void loop gets iterated infinite number of times, or it gets executed infinite numbers of times. So this keeps on happening. Now before we upload the program, we should make sure our Arduino is connected. So here I have the USB and Arduino. So I'll quickly go and connect this to my laptop. Now once I have connected this to a laptop, so you know the steps. Then we have to go to tools, we have to verify the board. The board is Arduino Uno, yes, that's the board. And port, you have to go and select the port which is the port in which Arduino is being selected. So it by default selects automatically. Now after doing this, I can press on upload. So once I press upload, first it verifies, it compiles, and then if everything is okay, then it uploads, or else it prompts for an error. So as you can see here, you can see the bar in which it shows the percentage of compilation. So now it's uploading, and you can see done uploading. So once you see done uploading, you can see the output in my Arduino that the LED, onboard LED pin number 13 is blinking. You see this, and we have given a delay of 1 second. So that's why it's blinking in delay of 1 second. So can we alter this? Yes, we can. So now this delay is 1000, right? So I'll give 3000. That is nothing but equivalent to 3000 milliseconds. That is nothing but 3 seconds. So now if I upload this program, and once the program is done uploading, so now you can see it is high for 3 seconds and then low for 3 seconds. You can see this. So based on your requirement, you can customize this for your LED blinking. Now you have seen this example, whatever is discrete, that is we have used digital, right? We are using a discrete writing technique. Now what if I have to use analog? What if I have to fade or I have to give some intensity? So in order to give intensity, then we cannot use analog, right? We cannot I'm sorry, we cannot use digital, right? We have to use analog, right? So what I have to do is, in this void loop part, I'll quickly go and remove this, and in this void loop part I'll add a for loop in which I'll say int I is equals to 0, then I'll say I is lesser than equal to 255, then I'll say I plus plus, because the max color you can give is 256. Yes. Now once I do this, I'll write analog write. So I'm writing analogly. So when I say analog write, I can give a continuous values. It is not discrete, it is not fixed, so it can vary. So I'm saying pin number LED. So from LED variable getting pin number 13 comma I. So initially it will be 0 1 2 3 4. So as you see, the intensity increases, and I'll give a very small delay of maybe 10 so that you can see these. Yes. Now so this is to increase the intensity. Then we have to write the program to decrease the intensity. So I'll quickly go and write for loop, and I'll just reverse this. I'll say I will be 255. I'll say I will be greater than or equal to 0, and I'll say I minus minus. So this way what happens is, now I'm decreasing the intensity. And again, so I'll write analog write, and I'll give LED pin comma, I'll give I value, so it keeps decrementing, and I'll give a very small delay so that we can see the light. So now I'll quickly go and upload this program, and then we'll see that the LED intensity increases and decreases slowly. It increases and decreases slowly. Now because I've given less delay, you cannot see it properly, so I'll quickly go and give 100 milliseconds delay so that it's even more slow and you can see the output. So again, based on your requirement, you can customize this. So now you can see the intensity is slowly increasing and it is decreasing. Yes. So based on your requirement, you can use analogs, right? Or you can use digital, right? If you want discrete value, if you just want the LED to be on off, then you can use digital, right? Now if you want to vary the intensity, then you can go ahead and you can use analog write. So this is how basically we write an onboard LED program. Now LED onboard LED program, it's just like, you know, you're writing the starter program. So basically when you're new to programming, so you write a hello world program, and coming to physical world, so you're coming to physical world, writing a blink LED program is the starter program or a hello world program. So this is very important.